Okay class, today we're going to be looking at the topic called inverse functions. An inverse function is kind of the opposite function. We start off with a function with domain D and range R. Then it has an inverse, which is denoted as f with a -1 exponent of x. That does not mean we're going to take it to the -1 power. It does mean that the domain and the range are going to switch values. Specifically, I should be able to plug, if I originally have a function, I plug a point A in for my x, I get a b value. Then my inverse function, if I plug b in there, I'm going to get a as my answer. To look at an ordered pair, if I start off with a comma b as an ordered pair, it's going to become b comma a in the inverse. So what we're going to do is we're just going to jump into finding a couple inverses algebraically. We're going to look at a table and find the inverse of that, and we'll discuss this a little bit more when you get back on Monday or Tuesday. So our first function we have is f of x is equal to 2x plus 5, and we're asked to find the inverse of x. So our function starts off basically as y is equal to 2x plus 5. Now what we're going to do is we're going to switch x and y to find the inverse. I'm going to have x is equal to 2y plus 5. Now we don't like seeing a function that has y with parts of the equation and x over being by itself. So what we're going to do is we're going to solve for y at this point. I'm going to start by subtracting 5. And I've got x minus 5 is equal to 2 times y. I'm going to divide both sides by 2, and I have to divide everything by 2, and so my answer would be x divided by 2 minus 5 divided by 2 is equal to y, and that would be the function for f inverse. Let's go ahead and do another example. If we started off with the equation f of x is equal to 3x minus 6, what we're going to do, of course, f of x means y, so we started off with y is equal to 3x minus 6. To find my inverse, f -1, with the little -1 exponent of x, I need to first set up my x is equal to 3y minus 6. I now need to get the y by itself, so I'm going to start by adding 6 to both sides. I've got x plus 6 is equal to 3y. The next thing I need to do is I need to divide everything by 3 to finish getting my equation by my y by itself. So I've got x divided by 3 and 6 divided by 3. So x divided by 3 won't reduce any, so I've got x divided by 3. However, now I've got that 6 divided by 3. 6 divided by 3 is 2, is equal to y. I have the y value by itself, and I am done. Let's look at another example. Now we have a square root. So this equation, we started off with y is equal to the square root of x minus 3. I'm going to start by switching my variables. So x is equal to the square root of y minus 3. So this y minus 3 is grouped together under the square root. So I have to cancel out the square root first. I'd start by squaring both sides, and that cancels out my root. So I've got x squared is equal to y minus 3. So to finish getting the y by itself, I'm going to add 3 to both sides. I've got x squared plus 3 is equal to y. And I'm done. Next value, we've got f of x is equal to the square root of x plus 2. Almost identical to the last problem we did. So y is equal to square root of x plus 2. And so I'm going to switch the variables. X is equal to the square root of y plus 2. To cancel out the square root, I'm going to start by squaring both sides. And so I've got x squared is equal to y plus 2. Now I'm going to subtract the 2 to the other side. And I'm left with x squared minus 2 is equal to y. And I finished solving for y. There's my answer. Now I've got up to f of x is equal to x cubed, or y is equal to x cubed. So I'm going to start by switching my variables. X is equal to y cubed. Now, to cancel out a cube, you're going to do almost the exact same thing you do if we had x is equal to y squared. So I'm going to do that over to the side. Over here, we would square root both sides, and we're left with y is equal to square root of x. On this one, we're going to take what's called the cube root, so it looks like a square root. However, this time we have a little 3 kind of hanging off on the little ledge here, and that'll cancel out the cube. So I have y is equal to the cube root of x, and at that point, we're finished with this next example. So now we have f of x is equal to x cubed plus 5, or y is equal to x cubed plus 5. I'm going to switch my variables. So x is equal to y cubed plus 5. I'm going to solve for the y, and so I'm going to start by subtracting 5 to the other side. So I've got x minus 5 is equal to y cubed. I cube root both sides, the same as I did on the last example. And I have y is equal to the cube root of x minus 5. Y has been solved for, so I'm finished. Let's do another one. We now have f of x is equal to the cube root of x plus 5. So y is equal to the cube root of x plus 5. To find the inverse, f to the f negative 1 of x, the inverse, we never actually want to call it by the negative 1. We just read it as the inverse function. We're going to switch the variables. We've got x is equal to the cube root of y plus 5. So if I had the following equation, let's say I've got x is equal to the square root of y, we would square both sides to cancel out the square root. So almost identical to what we were just doing, to cancel out the cube root, we'll have to cube both sides. So now I have x cubed equals y plus 5. To solve for y, I'm now going to subtract the 5 to the other side, and I've got x cubed minus 5 is equal to y. And I'm sorry about the look of that 3. I know it's kind of ugly up here, but I'll get better at this. So our next equation, we've got the cube root of x minus 2. So y is equal to the cube root of x minus 2. So to find the inverse, I'm going to switch my x and y around. I've got x is equal to the cube root of y minus 2. So again, to cancel out the cube, I'm going to cube both sides, just the same as if I was canceling out a square with a square root. So I've got x cubed is equal to y minus 2. Now to finish solving this equation for y, I'm going to add 2 to both sides. So I've got x cubed plus 2 is equal to y. And I'm finished because I have the y solved for. Our next equation, this one we have 2 x's in it, which means when we set up our inverse, we're starting off with y is equal to 2x minus 3 over x plus 1. So when we find our inverse, now we have x is equal to 2y minus 3 over y plus 1. This is no good because now we have these 2 y's that we have to get rid of. We somehow have to turn that into 1 y. And so we're going to have to do a little bit of factoring. So what we're going to do is we're going to start off by multiplying both sides by y plus 1. We cannot solve for a variable while it's in a denominator of an equation. So on the right hand side, I'm left with 2y minus 3. I'm going to go ahead and distribute on the left. So I have xy plus 1x, or just x. Now I'm going to put all my y's on the left and all my other stuff on the right. So I'm going to subtract 2y to the other side. I don't have any like terms because this other term that has a y has an x with it. And I can't combine the x and the negative 2. So I've got xy minus 2y plus x is equal to negative 3. Now I've got a term on the left side that does not have a y with it, so I'm going to take that x to the other side by subtracting. And I'm left with xy minus 2y is equal to negative 3 minus x. Now, at this point, we're almost done with this equation. So, at this point, I can kind of tell something. Over here on this left side, both of these terms have a y. And so what I'm going to do is I'm going to take that, I'm going to say that's my greatest common factor, and I'm going to take it out. So I'm going to take my y out here, and what I'm left with on the inside is the x minus 2 is equal to negative 3 minus x. So I've got y multiplied with x minus 2 is equal to negative 3 minus x. To cancel out the multiplied by x minus 2, I'm going to divide both sides by x minus 2. And I'm left with y is equal to negative 3 minus x over x minus 2. I've finished solving for y, and I'm done with that example. So one more fraction equation just so we can make sure we're good with that. So we've got y is equal to x plus 3 over x minus 2. I'm going to switch my variables to start solving for the inverse. I've got x is equal to y plus 3 over y minus 2. Again, I've got one of these fractions, and I cannot solve for y while it's at the bottom of a fraction. So I'm going to multiply both sides by y minus 2. And I'm going to go ahead and multiply this in the same way I did earlier. On the right side, I'm left with y plus 3. And on the left side, I now have xy minus 2x. So what I did earlier is I want the y's on the left, and I want anything that does not have a y on the right side. So I'm going to subtract y to the left side. And so I've got xy minus y minus 2x is equal to 3. So I've got this 2x on the left side. The 2x needs to not be with the y's, so I'm going to add the 2x to the other side. And now I have xy minus y is equal to 3 plus 2x. So to finish this problem off, I'm going to go ahead and kind of insert something here, because I know that this one lonely little y here, there's one of the y's. So what I'm going to do, again, I see I've got a greatest common factor on the left-hand side. I'm going to factor that out of the equation. And what I have left now, in the parentheses, I've got the x minus 1 is equal to 3 plus 2x. Now to finish solving for y, I'm going to divide both sides by x minus 1. And I've got y is equal to 3 plus 2x is equal to x minus 1. I've got the y by itself, and I'm finished. So the last thing we need to talk about is a table. The tables are actually really, really easy to handle because of the definition. If I have a comma b, then the inverse has b comma a. Now when you're connecting the dots on a graph, the only thing to keep in mind is that they have to connect in the same order that they started in. So if I'm trying to find the table of f inverse here, I'd have negative 64, negative 4. If I've got negative 2, negative 8, it will switch to become negative 8, negative 2. 0, 0. Doesn't really matter if we switch that. 2 comma 8 would become 8 comma 2. 4 comma 64 would become 64 comma 4. And that's all we have time for today.